Hi there, future teacher. Welcome back to your FTCE Professional Education Test Prep, brought to you by TeacherPreps.com. In this video, we're covering Competency 3, Instructional Delivery and Facilitation. This competency is tied as the heaviest area on the exam at 18%, roughly 14 questions. It covers how you actually teach, motivating students, delivering content effectively, differentiating instruction, providing meaningful feedback, and addressing misconceptions in real time. Every question in this competency boils down to one core idea. What should the teacher do in this situation? Before we dive in, we put together a free study guide workbook that goes along with this video. It has all the key terms, comparison tables, practice questions, and space for your own notes. Grab your free copy from the link in the description. This video is brought to you by TeacherPreps.com. Our FTCE 083 prep includes a complete study guide covering all 8 competencies, full-length time practice tests that match the real exam format, and AI-scored constructed response practice. It's free to get started. All right, that was our plug. For the rest of this video, it's go time. Grab your pen and paper. Here's what we'll cover in Competency 3. First, motivational strategies, including intrinsic versus extrinsic motivation and self-determination theory. Second, content area literacy and how to teach reading across disciplines. Third, analyzing knowledge gaps and addressing student misconceptions. Fourth, connecting content to real life and across disciplines. Fifth, higher-order critical thinking and questioning strategies. Sixth, differentiated instruction using Tomlinson's model. Seventh, providing effective feedback. And eighth, accommodating all learners, including students with IEPs, 504 plans, English language learners, and gifted students. Let's jump right in. Let's start with motivational strategies. On the exam, you'll see questions asking which approach best motivates students. The key distinction is between intrinsic and extrinsic motivation. Intrinsic motivation means engaging in learning for its own sake, curiosity, personal interest, the satisfaction of mastering something new. Extrinsic motivation means engaging for external rewards, grades, stickers, prizes, teacher praise, or avoiding punishment. Here's what the research tells us and what the exam will test. The goal is to build intrinsic motivation. While extrinsic rewards can help establish initial engagement, over-reliance on them actually decreases intrinsic motivation over time. This is called the over-justification effect. If you give a child a sticker every time they read, they start reading for the sticker instead of for the love of reading. When the stickers stop, the reading stops too. On the exam, the best answer almost always involves strategies that build intrinsic motivation, not adding more external rewards. The theory the exam draws from most for motivation is self-determination theory by Deci and Ryan. It identifies 3 psychological needs that drive intrinsic motivation. First is autonomy, the sense of choice and control. You foster autonomy through choice boards, learning menus, and student-directed projects. When students feel they have a say in their learning, engagement increases dramatically. Second is competence, the feeling of being capable of success. You build competence through appropriate challenge levels, specific feedback, and making progress visible. Tasks that are too easy bore students. Tasks that are too hard frustrate them. The sweet spot is what Vygotsky called the zone of proximal development. Third is relatedness, the feeling of connection to others. You promote relatedness through community building, collaborative tasks, and positive teacher-student relationships. When students feel they belong, they engage more deeply. Beyond self-determination theory, here are additional motivational strategies the exam loves to test. Relevance. Connect content to students' lives, interests, and future goals. When students see why something matters, they engage more deeply. Novelty and variety. Change modalities every 10 to 15 minutes. Use games, movement, technology, and varied activities to maintain attention. Goal setting. Have students set, track, and reflect on their own learning goals. This builds both autonomy and competence simultaneously. Curiosity hooks. Open with a question, a demonstration, or a provocative statement that creates a need to know. For example, instead of saying today we'll learn about density, drop a golf ball and a ping pong ball into water and ask, why does one sink and one float? That curiosity gap pulls students into the lesson. Next up, content area literacy. Here's a key principle the exam tests. Every teacher is a literacy teacher. Reading a science textbook requires different skills than reading a novel. A social studies primary source is structured differently than a math word problem. You must teach students how to read within your specific content area. First, teach text features, headings, bold terms, diagrams, captions, sidebars, and glossaries. Science texts are loaded with diagrams and data tables. Social studies texts use primary source excerpts and maps. Students need explicit instruction in how to navigate these structures. Second, teach academic vocabulary explicitly. Use the Freire model, which has 4 quadrants: definition, characteristics, examples, and non-examples. Also use word walls and morphology instruction, teaching roots, prefixes, and suffixes. Third, use writing-to-learn activities, journals, exit tickets, learning logs, and short constructed responses. Writing forces students to organize and consolidate their thinking. Fourth, model comprehension strategies through think-alouds. Read content area text aloud and verbalize your thinking process. I noticed this heading says causes of the Civil War, so I'm predicting this section will list specific reasons the war started. Now let's talk about analyzing knowledge gaps and addressing misconceptions. Identifying gaps requires using multiple data sources, formative assessment results, student work analysis, questioning during instruction, and error pattern analysis. The key is looking at what students get wrong and why. Different root causes require different interventions. For example, a student who adds fractions by adding both numerators and denominators has a conceptual misunderstanding, not a careless error. That needs a different intervention than a student who understands the concept but makes computational mistakes. A misconception is different from a simple knowledge gap. It's a firmly held incorrect understanding. Misconceptions are resistant to change because students have constructed them through their own reasoning. Simply telling them the correct answer does not work. The exam tests the conceptual change model, a 4-step process. Step 1. Elicit the misconception. Make it visible through questioning or prediction tasks. Ask students to predict what will happen before an experiment. Step 2. Create cognitive conflict. Show evidence that contradicts their belief. If a student believes heavier objects fall faster, drop a heavy book and a light book simultaneously. Step 3. Introduce the correct concept. Now that the student sees their old understanding doesn't work, they're ready to accept the new information. Step 4. Give students opportunities to apply the correct concept in new contexts to solidify the change. On the exam, if a student has a misconception, the correct answer is never tell them the right answer. It's always help them discover the conflict through evidence. Let's talk about connecting content to real life and across disciplines. Use culturally relevant examples and real-world applications. A fraction lesson becomes more engaging when students calculate recipe proportions for a class cooking project. Make interdisciplinary connections. Math appears in science experiments. Writing appears in social studies research. Data analysis appears across every subject. When students see these connections, learning becomes meaningful. Design thematic units that integrate multiple subjects around a central theme. For example, a unit on water could include science experiments on the water cycle, math activities on measurement and data, social studies research on water access around the world, and persuasive writing about conservation. Connect content to careers, current events, and community issues. Here's the exam tip. Questions about engagement and relevance almost always have the correct answer that involves connecting content to students' lives, not adding more worksheets or homework. Now let's cover higher-order critical thinking. The primary tool for developing critical thinking is strategic questioning. Use Bloom's aligned questions that progress from recall to analysis and evaluation. Don't just ask, what year did the Civil War start? Instead ask, why did the economic differences between the North and South make conflict increasingly likely? Socratic questioning is a dialogue-based approach where you probe assumptions, clarify concepts, and explore implications. Instead of telling students the answer, you guide them to discover it through carefully sequenced questions. Here's a critical exam topic: wait time. After posing a question, wait at least 3 to 5 seconds before calling on a student. Research by Mary Budd Rowe shows that increasing wait time leads to longer and more thoughtful student responses, higher participation for more students, and fewer, I don't know answers. Most teachers wait less than 1 second, which favors quick responders only. Also use open-ended questions with multiple valid answers. These require students to think critically, not just recall facts. Let's look at 2 thinking routines the exam may reference. First is See, Think, Wonder. You show students an image, artifact, or data set and ask 3 questions. What do you see? This is pure observation, no interpretation. What do you think about that? Now students make inferences. What does it make you wonder? Now they generate questions. This routine moves students naturally from observation to inference to inquiry. Second is Claim, Support, Question. Students make a claim based on evidence, support it with specific details or data, and then raise a related question for further investigation. This builds argumentation skills and teaches students that good thinking doesn't end with an answer. It generates new questions. Differentiated instruction is a major topic in Competency 3. The exam draws heavily from Carroll and Tomlinson's model. Tomlinson identifies 4 elements you can differentiate. First is content, what students learn. You adjust the complexity level or the reading level of materials. Some students read the original source, others read an adapted version. Same learning goal, different access points. Second is process, how students learn it. You vary the activity type, grouping arrangement, and scaffolding level. Some students work with manipulatives while others use abstract representations. Third is product, how students demonstrate learning. Give choice and format. One student writes an essay, another creates a presentation, another builds a model. All demonstrate the same understanding through different means. Fourth is learning environment, where and how students work. This includes flexible seating, noise levels, and whether students work independently or collaboratively. Great work covering instructional delivery so far, motivation theory, scaffolding, questioning strategies, differentiation, and grouping. But you're only halfway through Competency 3. You still need to master technology integration with the SAMR model, formative feedback loops, accommodations for IEP, 504, and ELL students, gifted learners, universal design for learning, and 4 practice questions. To pass the FTCE 083, you need all 8 competencies. Get the complete study guide plus full-length practice tests at TeacherPreps.com. Link in the description.